astronomy stuff now. But I refer to Rachel, or anything that's bigger than the galaxy.
Hi, I'm Carl Gallagher. I'm here as a rocket scientist, which is a fun way to say aerospace engineer. I have worked on developing rockets and satellites. These days I do jet planes. This is an exciting one for rockets. So, yeah, any questions on it?
Okay, those are your scientists. So now the arrangement is you ask them questions. Otherwise, it'll be a short panel. First question in the back.
Can you give us your thoughts on the Artemis 2 project going on right now?
I have mixed feelings on Artemis 2. It is awesome to see people getting closer to the moon than the Earth. I was at the Space Frontier party last night, and they were approaching the midpoint between Earth and Moon. So it's great to see people far and away again. I was a little nervous about the launch because the people who made their solid rocket boosters were 2 for 4 on doing the Vulcan boosters without pieces falling off. So I was very relieved to see they had a good takeoff. Yeah, they're having trouble with their email, they're having trouble with their toilet. This is normal, this is actually, if that's the news we're hearing about, that is good news. That means nothing really wrong is going on. The really nervous part of the mission is going to be their re-entry because they're using the same kind of heat shield as Artemis 1, which some months after landing, NASA finally broke down and revealed that chunks had come out of the heat shield of Artemis 1 during re-entry. And so they're not going to use that heat shield on Artemis 3 and on. They have, they've developed a new one, and that's going to be going forward. They're still using the same one on Artemis 2, so they're going to use a different trajectory in the hopes that the different heating profiles will not lead to chunks popping out or other bad things happening. This is not giving, this is giving the managers of the program a warm and fuzzy. The administrator accepted their assurances and signed off on the mission. I am among many people, including a bunch of former astronauts, who do not have a warm fuzzy about this, so we'll be praying their attention.
In the room?
Yes, I have a question about the second most famous equation, which is said to be the existence of extraterrestrial life. So I wanted to know.
I'm guessing that one's for Navy cities.
Yes. Well, I like the whole panel, but you specifically. But my question is, has the components within that equation, has it improved? Has the numbers improved in the ability to calculate that number based on the improvements in the ability to know how many planets there are and how much, in other words, has the equation gotten more precise?
So for those who may not know this particular equation we can reference, one of the founders of the SETI Institute was Frank Drake. In the 1960s, when he was working at the National Radio Astronomy Observatory, he organized one of the first conferences on what became radio SETI, looking for any radio transmissions from hypothetical aliens. We got a time there. Sorry. Frank tried to organize the conference based on an agenda of breaking apart the problem of looking for aliens. He did this by writing down an equation. Drake equation, supposed to be the number of the transmitting groups in the galaxy at any given time. And he takes the number of stars in the galaxy, divides by the age of the universe, multiplies by the fraction of stars that have planets, and the fraction of planets that have life, and the fraction of times that life starts producing radios, because that was his definition of intelligence. And then multiplies by how long that period lasts. We know how many stars there are in the galaxy, depending on how you count the brown dwarfs, it's a few hundred billion. We now know that there are more planets than there are stars, thanks to lots of exoplanet science over the last 30 years, and careful measurements of stars getting tugged around and planets passing in front of them. We know that some percentage of those planets are not too dissimilar in size and in temperature than the Earth. Beyond that, we do not yet know anything. There's new instruments being built, the extremely large telescope that is being built in try to get detailed atmospheric and surface composition information on some number of the exoplanets. And then we can start saying things like, if there's oxygen and lots of carbon compounds on the surface, there has to be something that's constantly extracting energy to make that stable. Maybe that's life. But beyond that, we do not yet know.
If I can comment on that, I'd like to put in a good word for biology broadly conceived, that we also know, or anyway, the relevant specialists know much more about the origin of life and the nature of life on Earth than we did in 1961 when that equation was written down. So we've actually made a huge amount of progress in that, but I'm not sure that makes us any more confident, makes a biologist, a biochemist, or any other relevant specialist I don't know if they have shrunk the error bars on the likelihood of life arising on a certain planet or anything, but I think like they know much more than they do. So let's cheer them as well as the exoplanet scientists who have given us much more confidence in a couple of the other numbers.
You and then you.
So a wide open question to the panel, just over the past year, has there been certain developments or things that you find interesting that you wish would be more widely shared, or just that you're interested in? Now, this may not be specifically your field. I'm assuming that you have a wide variety of interests, but especially your field. So just, is there something cool that's out there?
I'm going to jump in, even though I'm the moderator. We have a gene therapy for sickle cell anemia now, and it works. It's amazing.
Well, that might work. This might not be really super exciting, but we had this, like 2 years ago, we got legislative funding for a mobile monitoring trailer so we can send it around when people report air pollution in certain areas. We can send out a mobile monitor. It'll be up and running within the next 2 months, I think. But yeah, it's super cool. It's got all this instrumentation in there, and I'm just super amazed at that thing. It's really exciting for us.
I have one. So some of you may have heard of an object called 3i Atlas. So this is a comet that came into our solar system from the outside. The 3, you notice, is the third one we've seen like this. The previous 2, one acted like an asteroid, one acted like a comet. If you see asteroids and comets get thrown out of our solar system, you can blame Jupiter. They get too close in the wrong direction, they do gravity slingshot, they escape. So it's predicted we should see these things coming in, but nobody really knew how often that should happen. We've now seen 3, so we have statistics you can do, but not many. The exciting new part here is something called the Vera Rubin Observatory, which is just beginning operations in Chile the past couple of weeks. And it's designed to cover large chunks of the sky, find lots of near-Earth asteroids, where I interact with the Vera Rubin folks, but they also will find things that are moving too fast to be bound to the sun. Those will be new interstellar objects. How many they find, we're not sure yet, because we'll be finding smaller ones that are fainter than the other surveys have found. We don't know the distribution of things out there. So hopefully we've got a 4i, a 5i, but I don't know how high it'll go by the end of this year. We'll see.
So we already mentioned Artemis II, which is a dramatic half-century milestone of leaving low Earth orbit again. But it's been an interesting year in the rocket business in other ways. SpaceX got their version 2 Starship debugged to the point where it can do a nice hover and touchdown over the ocean, and made a lot of developments on it. Shield, that were running experiments on that. The Blue Origin New Glenn rocket did 2 successful flights, and they actually recovered the first stage on one of those flights. which is dramatic thing, because now not only are we recovering reusable things, but we have more than one outfit doing it. Because up to now, this had been an exclusively SpaceX thing. We have some Chinese outfits building their own recoverable rockets. So the rocket business has entirely changed, which I love, because 15 years ago, I'd go to a con, I'd be on the space panel, and it's like, okay, the program that we talked about last year had its budget cut, so that the schedule has slipped, nothing back. And now it's like, well, this rocket's flying, this one's flying. Later this month, we can expect to see SpaceX fly Starship again. First one of version 3, so explosion seems to be with that. It takes a few flights to do.
It's not exactly new news from the past year, but something I recently realized is, who's seen Star Trek 4, AKA the one with the whales? Yeah, right, so it turns out, they had this whole thing about how they could go back in time to get the whales, the humpback whales, because they were extinct in the time of the Star Trek future and Captain Kirk and everybody. Well, we are not in the Star Trek timeline for multiple reasons, but one of them is that the humpback whales are not going extinct. They're no longer in danger and are actually doing quite well because people changed what they did. So there you go.
I think the thing that led to the extinction, or the near extinction of the total extinction of humpback whales in the Star Trek universe was, unfortunately, when they invented the photon harpoon, and the people in the Starfleet universe hunted the whales down.
I guess I have a question about gamma radiation. Assuming I'm in something like the Artemis, and I'm going to be spending weeks or months it takes for me to go to Mars and back, hopefully, what's the likelihood that somewhere along that way I'm going to get a snout full of gamma radiation that's going to do me a world of hurt?
Well, okay, it's pretty likely that there's going to be a bunch of radiation hitting your ship, but this is something that can be analyzed, and if you're bringing enough supplies to spend a year or more on Mars, then you can use that, particularly your water, your propellant for your vehicle, and you have all of that to create a storm shelter for your crew, so that you will be shielded from solar radiation.
To elaborate a little bit there, the radiation hazard is not actually gamma rays. It's mostly from the solar wind, lots of protons and electrons. You get electrocosmic rays that come in too, and those get converted to gamma rays depending on what shell your spacecraft is made of, but that can be a problem. But the real concern is solar storm comes along, runs over the spacecraft, and now you have 100 times the radiation density all at once. This has been studied with spacecraft monitors on flying spacecraft to Mars, and studied with the first Orion spacecraft flight. They flew ghosts, they call them, radiation models for human equivalent. They looked at different parts of the spacecraft and see what the radiation dose is. They also did not launch the spacecraft last week until they got clearance from the heliophysicists who monitor the sun. Confirmed that coronal mass ejection that just went off is going to miss the Earth and the Moon, and not going to come near the spacecraft. You can do that even in advance. You can't really do that 6 months in advance. So for a mission to Mars, which Orion isn't really designed for, but they designed it for near-Earth asteroid missions where you can do 3 months out, then you worry about that. As you mentioned, you can pull everything out of the supply cabinet, stuff it around there, and hide inside, and just hope you don't get too many radiation hits in the process. I don't envy the astronauts pile on top of each other in a closet if this has to happen. That is the procedure.
So I walk at St. Paul's biggest park every Tuesday, Big Side Regional Park. There's 15 million cubic yards of our trash there from the 50s and 60s, with 20 million times the forever chemical in the water, the aquifers. And we're gonna somehow clean it up, but the only way is to, one, pile it in the park, to add to somebody else's pile. And when I read science fiction, I just can remember one story where recycling was mentioned, and at the time it was real cool, because if I order was eating garbage, you know, for the scale. I go, wow. But then we're talking about all these really neat science things, you know, with big parts and rockets and more and more and more, and we put it in stories and we're doing it in real life. And how can we recycle that stuff plus the salt that accumulates, the forever chemical, the microplastic, we call it purable? Are there science solutions for that? I don't see us talking about even not doing stuff.
It's to you.
This is me. I'm not in the water side of things, I'm more in the air, but I hear a lot. We did do some PFAS studies for air.
For chemicals.
Forever chemicals. Yeah, and a lot of it's this whole thing. So what I always say when I say PFAS compounds, there's something on the order of 15,000 different isolated chemicals that fall under that umbrella. So it's really hard to like test for one, right? And they're completely synthetic, so there's nothing that we have that will really break them down. That's why they're called forever chemicals. They're just, as far as tech, the main thing I know about the water chemistry is they test the health of the system by testing how much life is in it. If there's little life in it, that means it's not good for us. Because the chemicals there's so many, and it's just too hard to test for all of them. This is not like Star Trek where you just aim your thing at, oh, this has this and this and this. That's not how the analysis works. Like, I test for one of the tests I do is for carbonyl compounds, and I test for 7 carbonyl compounds, and I can only test for those. Like, I can't, it doesn't work the way a lot of people think it does. So there are some I have to say that there are some very passionate people at the Pollution Control Agency, and they are doing their hardest to try to solve some of these problems, get the funding, get grants out there, stuff like that, to try to solve some of these problems. I know they have a whole system, a whole process they have for cleaning up, like Oakdale and Lake Elmo and a lot of those areas that were polluted by 3Ms. Because 3M was producing a lot of PFAS compounds. They produce the starting products to make a lot of them. So they have the waste involved in that. So there's processes in place, but there's a lot of resistance, and it costs a lot of money, and to break these chemicals down, there's a lot of energy involved, so there's a lot of moving parts. But I'll have to say that the shining light is there are some very passionate people involved in all of this, and they really want to solve some of these problems. They really, a lot of us at the Pollution Control Agency really believe in our mission statement is to improve, what is it? Now I'm blanking. Sorry, I'm blanking on our mission statement. But but it's to improve the environment and human health. And so they take that human health part of it and they stretch it to its limits. Like anything that would affect human health, or they can okay, can we get carbon dioxide deemed a pollutant because it's a global warming compound, because this affects human health, and so they're really stretching the limits of what it means, and it's great. I love it. I mean, there's some really passionate people, and I love working there. But some of these problems are really hard and really complex, and we get there. So if you have that, there is a recording. There's a, you can go to the Pollution Control's website, take a picture, upload it. You have, as long as you have geo-tracking on your photo, it'll strip that, find out where it is, and I don't know if there's gonna do something about it, but it's recorded. During the ice, all that ice stuff, people report, tons of reports coming in because of the gas that they're using, the mace, and all that kind of stuff that they're using. There's all these reports of pollution, and I love it. It's great. So you should report it. If you feel like you should, just go to the Pollution Control Agency's website. There's ways of reporting these things, and hopefully we can get the funding. The more reports that come in, the more we can get funding from the legislature and take care of some of these problems. That's how we got the mobile monitoring trail, is because people went to the legislature, we got money for it, now we got it funded. So.
Okay, and to follow up, you were asking about fictional discussions of recycling. Pretty much any story that has nanotechnology in it, and there's a lot of real world work going into nanotechnology where essentially you have a less than microscopic assembly robot. That's something that can simply grab trash, pull out the atoms it needs, and so that is recycling, and so you would wind up just scooping out the old trash pits and feeding them to your nano assembly. And you can even go back to the stories from the 1960s. You'd have people take off their clothes and toss them into the basket to be disintegrated and reassembled as something else. So that is something that science fiction has been looking at, because it's not trash, it's raw materials, and that I think we will hit, maybe not in our lifetimes, but the work is being done to set up the foundation.
Okay, we had here, and then we had here, so you first.
Okay, this is kind of a follow-up to both the kind of pollution thing and space rocket launches. I have heard that SpaceX uses, basically they burn methane in their launch, which is, of course, methane by itself is a greenhouse gas. They generate tons and tons of CO2 with every launch, whereas is Artemis hydrogen oxygen, which is, at least the bulk is water that comes out of it.
Well, okay. The main engines of Artemis are hydrogen, oxygen, and then you have the strap-on solid rocket
like
boosters.
butyl rubber or something?
And the solid rocket, I think it's mostly ammonium perchlorate, but you get a hell of a lot of really nasty stuff out of it. So, SpaceX, the current Falcon 9 is burning kerosene, Starship is burning methane, Blue Origin is doing methane, the ULA Vulcan, which is the primary government rocket, that is doing methane plus solid rocket boosters, so you have the slightly cleaner methane mixed in with all of the harmful solid exhaust. So, I think we're improving on that, but while we're using the solids, we're still going to be getting a lot of nasty stuff from exhaust. Hydrogen, unfortunately, is for various practical reasons not a great fuel for lifting off from the Earth. It gave Artemis 1 a lot of trouble. The Artemis 2 launch crews managed to get that under control pretty faster, but it's liquid hydrogen is nasty stuff.
Sure, one additional thought on this one. There's also, bringing hydrogen. Where's the hydrogen coming from?
Methane. Right.
So you can
It's
get
not
hydrogen.
green
You
hydrogen.
can get hydrogen by splitting water, you don't have this problem, but most of it comes from methane being reacted with stuff. This is used to make fertilizer in humongous quantities, eats out the world. But there's still carbon dioxide showing up in that process.
Yeah, I'd like to add that, that the exhaust of a single rocket, discharging gases into the lower atmosphere and then the upper atmosphere is really pretty insignificant on the scale of the Earth's atmosphere. However, we have started to launch more and more rockets, and the number of launches we got every year is now increasing, and some of the companies that Carl mentioned have plans for much bigger rockets. And indeed, we're starting, I think we just crossed over 10,000 satellites that SpaceX alone has launched in the Starlink series. So now it's we're launching a lot of rockets, and they have a lot of implications. So the amount of gases or exhaust products that go into the atmosphere starting to be something worth looking at as a possible hazard. And another thing is that all of those objects that have gone into orbits that, more or less low Earth orbits, they're going to come down someday. This is in the plans of the companies, and the multi-thousand satellite constellations will have replacements for the dying ones. But it means that we're also attacking the atmosphere with hunks of aluminum falling down and burning up and making tiny particles of oxidized aluminum and tiny particles of whatever else the satellite was made of. And there's way less upper atmosphere than there is lower atmosphere. So sprinkling stuff up there has a larger effect than if you were sprinkling stuff into the wind down here at near sea level. And so again, scientists are beginning to look at the environmental effects of not a few hundred satellites that eventually come down, but thousands and thousands, maybe tens of thousands. SpaceX has some press releases that says, we want to put 1 million satellites up, and that, the environmental impact of 1 million satellites is something that they're only starting to look at, and I don't think SpaceX has thought about it much.
Okay, it's you, then it'll be you, then it'll be you, okay?
Another follow-up on the pollution question from a different angle, a little more upbeat. I guess I'm going to use the word rumor. I've heard a rumor that some scientists have discovered a bacteria out there in the ocean that eats plastic now. Did anybody hear about that? Does anybody know anything about it?
There are several bacteria that eat plastic now. Not quickly.
One concept that comes up a lot in science fiction nowadays is Kessler syndrome. That is, when the debris that's in Earth orbit hits each other, so you have a chain reaction that basically locks us out of orbit for however long. What are the probabilities of that actually happening, or is that just something they came up with?
It's happening now.
Oh shit.
So we talked about how there's 10,000 Starlinks in low orbit right now. They are actively controlled. If they did not continuously move them every certain number of seconds, they're moving one. There would be a collision between Starlinks in about 3 days. A friend of mine who works, Samantha Lawler at the University of Regina, has worked on this a lot, and that number keeps going down as they keep adding more Starlinks. Last week, a Starlink exploded. They apparently do this every so often because the design is not particularly robust to failure modes. So it's scattered a bunch of debris across the orbit level that it's in. The debris is relatively small, it will fall out of orbit really quickly, but if there weren't the active controls constantly moving the Starlinks, we'd have a whole lot more debris up there already. Now, it doesn't prevent space missions going elsewhere, because you go up through the debris cloud on one pass and the relative risk is pretty low. But it would make low Earth orbit unusable for a few years, which would be bad. So, I hope it doesn't get to that point.
I have a question about nanoplastics. What is the distribution, and how effectively can we remove it, say, from a drinking water? I've heard comments there were 7 milligrams in every nanoplastics in everybody's brain. Nanoplastics are not visible, not like microplastics. Plastics are 2 or 3 millimeters to about 0.1 millimeter, which is sort of this, below that you have nanoplastics. You cannot see them, but how can we get them from available water? Other than not drinking all of them.
I don't know that much about the nanoplastics. So he's basically asking about nanoplastics and how to get rid of them. Nanoplastics are smaller than the microplastics that we hear about. And so one of the real big issues with the nanoplastics is they're small enough to kind of just pass into your system. So yeah, they're going to get into your body. That's the biggest problem. And how do we take them out? We don't know. I don't know that much about it because I'm on the air side of things. I did work in plastics, but that was a long time ago. Yeah. So I'm sorry, I don't really have a thing. I'm told that this is how we ended up getting some of the bacteria that will eat plastics, because when they get small enough, then some microorganisms will go, hey, that's food, and they'll adapt to whatever food they have. And so this is what I've been told, but I don't know that I've really seen anything. I'm not on the life side of things. I'm on the, whatever, testing side of things. So I don't know.
I guess this is the sort of what goes in must come out kind of question. What goes up comes down. As regards these organisms or critters that eat plastic, what do they excrete?
I don't know. It's probably not as scary as you're building it up to be. I'm guessing it's not very exciting.
That's comforting.
From what I know about the life stuff, typically things will break down into its lowest energy. So that means carbon dioxide, alcohols, stuff like that.
I guess I'd kind of like to hear from the panel as to the state of the union of science in 2025, 2026, and where do you think the best place to put our resources are?
Which union?
The union of the world.
What's the quote state of the union type statement or your thoughts about how the world is doing science-wise and maybe turning science into technology, or turning science into ways we can defend against some of the serious hazards we've been talking about. I think you may have in mind that the United States has suffered a setback in the last couple of years. If you want to talk about the president's budget proposal that came out yesterday for fiscal year 2027, it's a complete disaster for American science, and has some bad implications for some international science. But it's also a partisan thing, and what the White House says they want for a budget is far from what various houses of Congress decide ought to be in there, and all of that will come out many months from now, and the president will have to sign a budget that isn't what he proposed, but is a compromise and has the opinions of the House and the Senate. And last year, when this struggle went on, the White House proposed a terrible, terrible reduction in the healthcare agencies, National Institute of Health and Center for Disease Control and so forth, terrible reductions in the National Science Foundation budget, dreadful cuts to the kind of NASA programs that I like, and whatnot. And, you know, the folks in Congress kind of put it back over the months, and the past fiscal 2026 budget which really wasn't real good for science, wound up being not as bad as we had feared. And so I think we may be reenacting that for the next couple of years as the struggle of opinions in Washington on science funding goes on. And you know, that's by the way, this is not NASA's opinion. This is my opinion, and that's probably an important thing to know.
The contractor, another national civil servant, I can say, call Congress and tell them to fund science. Civil servants have to stay quiet. Yes.
Another aspect on the state of science, which I think is an improvement, is we have been shaking out some stuff, I think, improving the overall quality, in that there's been a lot of ranging from careless to deliberately fraudulent science papers out there. The Alzheimer's field was particularly struck by that, to the point of where the president of Stanford got a slap because his laboratory was putting out fraudulent results in Alzheimer's research. And people have shaken out a bunch of other stuff like that in papers. And so I think we're getting, you know, improvement in the quality, that it's not just, you know, desperately throw something together to get enough publications and qualify for your PhD, but you actually have to get good work done. And I think that's going to give us better science on average.
One thing that I wish we did do more of, I wish there's some of this around the edges, is to not try to avoid this sort of annual funding cycle question. And instead, like, there's something called the decadal survey, for example, for a lot of space science kinds of things, where they basically plan out, this is what we'd like to do for the next 10 years. These are the missions that we, as the people working on this, propose as the most important. This is our rank ordering of which ones we should fund, given how much money we have. And I kind of wish we could do that on a broader scale, and with the actual 10 years of funding to go with it, so that the scientific progress is not as dependent on short-term political whims, or, you know, the desire of some political group to put their stamp on whatever the latest cool science thing is. It's that basically the science takes time to get anywhere, and it needs time and space to develop.
There have been cuts to graduate programs, particularly in biology, because they don't expect funding, so they're just taking fewer students. So we're really going to see cascading effects from here, because there just won't be as many scientists at the graduate level. Okay.
So, I'm gonna try to fish for good news here. What's the current situation with the Europa Clipper, and is the Titan Dragonfly mission still on schedule, and I guess still gonna happen?
I'll take that. I'll give a talk on Europa Clipper tomorrow at 1, if you're still around. Okay, so it's busy flying to Jupiter, and not otherwise very busy, and it will arrive in, I think, 2030, and then go through a years-long process of orbiting Jupiter in various ways, and observing Europa, and, you know, also observing whatever else comes to hand, you know, other satellites in its system or whatever. So that's the story of Europa Clipper. Dragonfly, I think I ought to do a Dragonfly talk, so I'm in the middle of doing my homework on the Dragonfly mission. Dragonfly is supposed to launch in 2028, I think, and therefore it's in the middle of getting built. They're bending metal. They're doing lots of testing on either the engineering development chunks of the spacecraft, if you want to call it a spacecraft. It's the second spacecraft with propellers. Dragonfly is an ambitious mission to send an aircraft, a rotorcraft, a drone, an octocopter. I want to bring back the word whirlybird. Okay. Send a whirlybird to Saturn's largest moon, Titan, which has a thick, cold atmosphere that is just lovely if you're into aerodynamics for operating a heavier than air aircraft. So it's a great whirlybird planet, provided you have a machine that can withstand the extreme cold of Titan and the other problems in its environment. So Dragonfly is an octocopter, maybe longer than this table and maybe not as long as that table. And it's loaded with instruments, and as I say, it's under development. And up till now, it's continued to be funded. It has survived or dodged the funding process. So that's maybe a long-winded answer, but that's often what you get from me, sorry.
Okay, I saw you and then you.
Follow-up question for Bill on the Dragonfly question. Speaking of Titan's atmosphere, I saw a story years ago in which it was suggested, given that that atmosphere is mostly methane and other hydrocarbons, that it would be feasible to build a jet craft using the atmosphere for the fuel and pure liquid oxygen or highly compressed oxygen for the oxidizer. I'm guessing that nobody is being that ambitious yet, but it would be interesting to know if the possibility is being studied. Dragonfly results might shed some light on the possibility.
Okay, if I take this one?
Yeah, sure.
So the atmosphere of Titan is actually mostly nitrogen. The methane outgas from the interior goes up to photochemically cycle it doesn't last that long.
Okay.
So the C's that you see in radar images from C, that's mostly heavier stuff, methane, propane. So you could react the methane with oxygen, but carrying around a tank filled with oxygen is really annoying. You heard about the problems with keeping stuff liquid or launching hydrogen to the earth. Oxygen isn't as bad, but it does still boil off. The further out you get from the sun, the less that is a problem, but carrying a tank of liquid oxygen for 10 years would be really annoying. Or whatever the flight time is for Dragonfly, trajectory. So what they are doing instead is they are taking a plutonium and using it as a RTG to power a battery, which will power the rotors for a certain number of minutes.
Yeah.
This also lets them land and stay put and take off in one spot. You don't have to have a long runway.
Oh, sure.
Which would be
I see the usefulness of some sort of rotor craft for the first flying probe. I was curious about the feasibility of the jet idea.
Well, the jet would certainly work. I mean, our atmosphere is mostly nitrogen, and it still work here. You just have to carry your oxygen or fluorine if you're being really ambitious. The problem is, for the mission, Dragonfly's mission is to check out what's going on at different spots.
Sure.
Rather than, okay, we want to map Titan in detail, a jet would be great because it can go around fast. For actually taking samples at lots of places, the land, use your RTG to recharge your batteries, and then use the batteries to fly to the next location, gives you a lot more spots.
I'm probably being optimistic enough to think about future Titan missions here.
Oh, there's a lot of future possibilities about Titan. I have a Titan story I wrote I will be looking forward to seeing if dragonfly trashes the hell out of them. That's part of the science fiction.
I'd like to add that the trick you describe would work in a hydrogen atmosphere or a methane atmosphere, such as the gas giants. So there's nothing wrong with the principle you described, but it won't work on Titan because there's only a small amount of methane. Imagine that an inventor thought of an engine that would power an aircraft on CO2, carbon dioxide, on Earth, right? Well, there's not very much of that in our atmosphere. It has a big effect on some things, because in atmospheres, a little bit of extra gas of one type or another has big effects. Like there's way less than 1% hydrogen water vapor in our atmosphere, but we have clouds everywhere and sometimes icebergs and stuff. If your inventor thought of a way to burn water vapor or thought of a way to burn CO2, then it would still not be practical to build a jet that used that power. Same problem on Titan.
Nitrogen burns if you work hard enough.
Yes. Just one last thought on Titan. There are other interesting things people have more seriously proposed. There are designs for a blimp to fly around Titan. There are designs for a boat to land the lakes on the North Pole. There was even a design for a submarine. But that had a problem because there's waste heat from the electronics of the submarine, and then it's boiling the liquid hydrocarbons around the submarine, which is a little awkward for steering. But people have considered all sorts of unusual things.
I was going to follow what Mike said. I do environmental water testing. And so one of the things I've done for a number of years is sampled invertebrates and streams, and you have little charts, and they go from 0 to 11, because you can tell somebody had a sense of humor when they came up with these charts. And depending upon how many of which ones you find, you can determine, oh, these love brackish and polluted water, and they're doing really well, and all the delicate ones are gone. And as we sampled, the streams were getting worse and worse over time. So, but it is, to answer what Mike was saying about using the actual creatures that are living there to tell you how healthy the streams are. And most of that was done with, this was in a rural area, so most of this was agricultural chemicals rather than industrial stuff. But on that same note, they were doing some rather advanced water, they being the Illinois State Water Survey, the Illinois State Geological Survey, were doing some rather advanced testing of some of our springs that tells you what's in the groundwater and some of the surface streams. And they were finding, like in my well, my farmhouse, and I'm half a mile from a neighbor, microplastics, caffeine, hand sanitizer, the chemicals they put in those hand sanitizers, which I don't use. So somewhere someone else is using this, it's going down into the pristine aquifer, coming through and coming up in my well, half a mile away. So this whole, the ground filters is not quite as accurate as they tell you on the beer commercials, where, the poisoned water, whatever that Wisconsin beer used to say, it's been underground for thousands of years, it's the purest water. It's like, no, it's really not. So I have 8 filters between what comes in through my well and what I drink, because I learned what was in my water, including reverse osmosis and a ultraviolet tank to kill anything that gets through, like with viruses. So it's already in there, even in rather pristine areas. I want to just say something about caffeine. There was a study in Minnesota tracing caffeine from farms in Dakota County to the Mississippi River. It is conservative, and these farmers were drinking a lot of coffee, and they traced the whole path in the groundwater system. So there are things we put in the ground that would be called conservative. They're not consumed by the biology in the ground. The other thing is, once you get below the water table, groundwater is reducing. It does not have very much oxygen to oxidize your contaminants. So you're likely to find a lot of nitrates, where the phone puts in, you'll find the caffeine, which makes it an excellent tracer. You will find dissolved oxygen down around 0. And you have to be careful where you're pulling your water from.
Okay, we are at 7 minutes left. I think I saw you put a hand up before. We got one hand here, and then we're reaching the end. So burning questions.
So quickly, regarding the issue about orbital collisions between satellites, I was reading a few stories here and there about problems between, Starlink for some, and with in particular Chinese satellites, because China has not been really good about cooperating with reporting orbital changes or launches and things like that. So my question is, has there been any progress, or are people actually working on instituting better cooperation to avoid the types of problems that arise as we increase the number of satellites, and the fact that there doesn't seem to be a lot of great cooperation between countries on coordinating these things?
There does need to be a lot more international cooperation here. It's not just the United States, it's not just China. Russia did an anti-satellite weapons test and it endangered the International Space Station, sort of by accident, because they did not tell anybody when they were going to be running one satellite into another. India's done the anti-satellite weapons thing too. That causes problems for a while, so there needs to be some international regulation here, and I don't know what form that would have to take.
I'd like to add that there is considerable cooperation on these issues. There are bodies that get together and get nations to agree on this kind of stuff. It's not a completely solved problem, but if you look into the weedy diplomatic details, there really is a system where folks that operate satellites let other people know about their hazards. Folks that are tracking bits and pieces of things in orbit issue a warning, or can predict that two spacecraft are going to come dangerously near one another very soon. And could you move your satellite, please? While there isn't cooperation among all the countries, we're more in that direction than not. The thing that there isn't good regulation of, or it's nobody's job to control it up till now, is light pollution that messes up optical and sometimes radio astronomy from the presence of satellites. And this is and suddenly putting up thousands of spacecraft in a decade or so has made this a brand new scale of problem for astronomers, and they're in the middle of scrambling to try to get some more diplomatic attention to this. Again, there's progress in that front, but it's far from being a solved problem.
Really, I don't think that's going to be solved at the national level. I think what's going to happen is operators are going to be talking to each other, and so you will be having possibly informally the Starlink operators, the Chinese operators. I forget the name of the system Amazon is putting, but all of these system operators are going to be talking to each other and doing informal, say, okay, if I move this satellite when you move that satellite, optimizing for reducing the amount of fuel they have to expend to avoid emissions. And there will be government-owned satellites, which will have their own formal process, but they will become a minority of what's up there, and the various system operators will just work with them. And eventually we will get to the point where we have active measures to putting systems up there to eliminate debris.
All right. So we had another question, but we only have 3 minutes. So I'm going to say, if you have more, capture your scientist after the panel. And I would like to just hear very short last up thoughts, and we could start with Carl and then move this way.
I did my rants already.
I do not have anything immediately to add, but I'll be around for more questions. You ask.
Nobody asked about big scale stuff, but I will note that dark matter is weird and dark energy is weirder, and you have no idea what those things are.
That's exactly what I was gonna ask about.
I just say, be curious.
I'd like to say that, that the questions were excellent, and the audience, as I expect from Minicon, is like really smart, so thank you. Also, we actually know a lot, we've made a lot of progress in the negative sense. We know a lot about what dark matter is, and I count that as an important contribution.
All right, have a good day. Come and grab your scientists.